So I got to share with you something that happened on a project I'm working on where I used uh, the Gemini AI system that's in Google Chrome. So what I'm doing is I'm building an analog computer using an operational amplifier, and I've never done much with op amps before, so it's a learning thing for me. Uh, and so what this thing looks like, I did some breadboard prototyping over here. Here's the breadboard. And it's kind of hard to see, but there's a little tiny integrated circuit chip right here that has two op amps on it. So I hooked up my voltmeter and a power supply, and the test I was doing here was to take two voltages and add them together and then multiply them by a constant. So here's the math that I did, and it worked perfect. Okay, so now I understand how the op amps work and how to wire the thing. So now I want to make a better one. So I've got this thing over here on the right, and so I've got the op amp chip here. I've got a plus or minus 15 volt power supply that comes in, and then on the front I'm going to have some. I've got some binding posts, and I'll use patch cables to program the thing. Okay, and the way the circuit works is shown here, and I won't go through the details of all this. But you got power coming in, and then I put the op amp IC on this little breadboard thing here. It's called a perma proto board. It's pretty cool that it works just like a breadboard, but you can solder the connections. And then over here I've got the inputs to it where three voltages come in and the op amp adds them together. And then there's an output scalar potentiometer here that will multiply the sum of those numbers by any number between 1 and 10, right? So what it does is it calculates equations in the form of a times x plus y plus z. And if you just want to have a simple sum, you just set a to 1. Okay. So I wasn't sure how to set up the inputs for to provide the numbers that are going to be added up. So what I've drawn here is a voltage divider. So you got 15 volts coming in the top of each one of these, and then the bottom of it is grounded. And so the wiper on the potentiometer goes into a 10K resistor, and those all come into one of the inputs on the op amp. But one of the things you got to do with the analog computer is to engineer in the range of values that it works with. So I've got 15 volts coming into this thing because that's what the op amp needs to power the op amp itself. But I don't want numbers from 0 to 15. I want numbers from 0 to 10. So I wasn't quite sure how to do that. So I said, well, let's see if AI can help me. And it's amazing what it did. Check this out. I'll lead you through the conversation here, and there's some just astonishing things that Gemini can do. So I start off and just said, create a voltage divider with 10 volts in, 10 volts out, with a 10K resistor and unknown second resistor. So it comes back and it tells me how to do it. It's got a picture of it. It's got all the resistor values. And it said there's actually two ways of doing it, because the way I worded it, I didn't indicate which resistor was the 10K, whether it's on the top or the bottom, and that makes a difference. So it answers both questions. Option 1 with the 10K resistor on the top, and option 2, the 10K resistor on the bottom. Okay. So then I said, with the 10K resistor on the bottom, what's the range if R1 is a 5K potentiometer? And it came back and it said 15 volts to 10 volts. Okay, well I don't want 10 to 15, I want 0 to 10. So I simply said I want the output range to be 0 to 10. So it says, oh, okay. we need to change how it's wired, and it describes how to do that exactly. And it gives me the resistor values and how to wire them, and it explains why this works. Okay, got it. So I wanted to test all this, and so I have a power supply that I thought gave me 12 volts. Turns out it's only 11. So I just said, change input voltage to 12 volts. Said, okay, you'll need a 1K resistor. So I put that in there, and before it said I need a 2.5K resistor with a 15 volt input. I said change it to 12, and it said, all right, you'll need a 1K resistor. Okay, so I do that. So I hook it up and I wire it up on my breadboard here, and it turns out my power supply only gives me 11 volts. So I said, all right, change the input to 11 volts. I said, okay, you'll need a 500 ohm resistor. So I set that up, and it works perfectly. But now check this out. So I've been having this conversation, and it says, are you planning to use this for a specific control signal, like a 0 to 10 volt analog dimming circuit or a microcontroller input? It's asking me, hey, what are you trying to do? And I said, well, it's an input to a summing op amp. And it says, oh, well, that changes things a little bit. And it describes how the resistor that acts as the input to the op amp loads the circuit. Okay? And it says there's two ways to handle this. Option A, the buffered approach, or option B, the passive correction. And it describes the components you need to do that. But check this out. It stopped and said, what is your intent? And so I told it the intent, and then it told me what I needed to know, not just answering the questions that I asked. Okay? So now it says, I decided to go with this option B, the passive correction, and it tells me the resistor that I need, and then it summarizes everything. And then I said, okay, let's go with the passive correction option B, input voltage of 15, summing resistor 10K. What is the value of the series resistor with a 5 ohm pot? And it goes through and does the calculations, and it says that series resistor needs to be 1.667 kilo ohms. And then it says, well, that's not a standard value, so here's a bunch of different ways of doing it. And then it says, important note on linearity. And it describes the non-linear, and it calls it an S-shaped curve. It said it'll be okay at the extremes, but in the middle, you're going to be off. You're going to get 4.3 volts instead of 5. And that's why the buffered option is the preferred one. And so it's telling me all this. And up above it talked about how the summing resistor and the bottom half of the potentiometer are in parallel. And I go back to my circuit, and I'm drawing it like this, with the 15 volts to the capping resistor, to the trim pot, to the summing resistor, and those look like they're in series to me, right? They're all in a row here. I said, well, wait a minute, I'm misunderstanding something. So I said, explain how the summing resistor and the bottom half of the potentiometer are in parallel. And it gives me an explanation. I won't go through it all here, but it makes perfect sense. And it explains it says you've got to look at it from the perspective of the potentiometer's wiper. And then it explains what that terminal sees, and then gives me the definition of parallel, and said, see, it's got they both start at the same place and end the same place. That's the definition of parallel, and then it does the math. So what's interesting about this is it started out answering my questions, and then it could tell that I was trying to do something bigger and asked me what it was. I told it, and it knows completely how an op amp works. And then it did all the math on all the resistors and all the components I need and how to connect them, and it gave explanations for why it works. This is unbelievable. So as I said, I'm not an expert in analog computing, analog circuits, and this is my first project with an op amp. So I'm learning. But another thing that's interesting to me is AI is teaching me, right? By giving me detailed information like this, like this linearity note, and explaining the why those two resistors are in parallel. It's just astonishing what this does. So yeah, here's why this works, and it goes through it in detail as to why it works, and it's explained in ways that are easy to understand. I wish some of my university professors would have explained stuff like this in simple terms like this. Anyway, I think this AI thing is just amazing. I thought you might be interested in this. All right, that's it. Thanks.